Hey everyone, geophysicist Stefan Burns here. 3I Atlas, this mysterious interstellar object which first was detected in July of this year, speeding into our solar system at about 60 kilometers per second, now is within 2 astronomical units of the sun, meaning it's closer to the main engine of energy and life in our solar system.
The faint trail of 3I Atlas glimmers as it drifts closer to Mars, and with it a surge of astonishment ripples across the scientific community. What was once a lonely traveler from interstellar space has revealed itself not to be alone at all. New objects are multiplying, forming a loose caravan that seems to shadow the original body. Each telescope pass, each refined calculation, unveils companions that no one had anticipated. It is as if the universe has decided to present a riddle written in celestial ink, and the answer lies just beyond the Martian frontier. Before we start, smash the like and subscribe buttons for more updates. Astronomers had expected 3I Atlas, following on the heels of Oumuamua and Borisov, to behave as a singular wanderer. Its trajectory slingshotting past our sun suggested another brief interstellar encounter, a reminder of the vast cosmic ocean from which it had come. Yet as it approaches the orbit of Mars, instruments have begun to confirm flickers and signatures that point toward a family rather than an individual. Some of these bodies are fragments, others appear more coherent, and a few even demonstrate faint atmospheres or tails, as though the journey through solar radiation has awakened something volatile within them. The sheer multiplication of these objects suggests processes that reach beyond simple disintegration. When comets fragment, their pieces usually scatter along predictable paths, but the behavior around 3I Atlas is different. The objects are not merely trailing debris, they seem to carry their own courses, loosely aligned but not entirely dependent on the parent body. This opens the door to questions about their origins. Were they bound together long before entering the solar system, perhaps as remnants of a disrupted interstellar object cluster? Or has some hidden physics sparked by interaction with solar wind and Mars' gravitational reach created a resonance that drew them into collective motion? The implications are staggering. Each new detection expands the opportunity for study. Instead of one fleeting visitor, astronomers now face a miniature fleet, each carrying information about conditions beyond our stellar neighborhood. Composition analysis will allow comparisons between the fragments, testing whether they share a common chemistry or whether they are diverse, hinting at a larger story. If their spectra differ significantly, it could mean that 3I Atlas traveled through a region where multiple bodies merged or interacted, carrying with them a composite history of the interstellar medium. That kind of diversity would be a rare chance to peer into the chaotic processes that sculpt planetary systems beyond our own. As the Caravan approaches Mars, the planet itself becomes an ally in observation. Mars orbiters and surface rovers, already equipped with high-resolution cameras and spectrometers, stand ready to capture views from a perspective Earth-based telescopes cannot match. A closer pass near Mars's orbit offers the potential to track the swarm from 2 vantage points, providing parallax that sharpens our ability to measure trajectories. It is as if 3I Atlas has chosen to deliver its revelations at a cosmic intersection where humanity has its machines stationed and ready. The multiplying objects also fuel speculation about interstellar structures. Could this be the first observational hint that rogue clusters exist, fragments from disrupted planetary nurseries ejected together rather than as individuals? If so, they may travel in loose companionship for millions of years, only occasionally betraying their presence when caught by the gravity of a star system like ours. The discovery would force a re-evaluation of models predicting the population of interstellar wanderers, moving the numbers from solitary figures to entire families adrift between the stars. At the same time, questions arise about stability. If these bodies are volatile, shedding gases and fragments as they warm, their interaction with Mars's gravity could produce additional splits. The next few weeks may bring an even greater multiplication, transforming one visitor into a complex, evolving cloud. The physics of such a process is not merely academic. It teaches how small bodies behave when subjected to multiple stresses, thermal, gravitational, and mechanical, providing insights into how early solar system material might have broken apart under similar conditions. The approach to Mars also carries symbolic weight. Humanity has long cast Mars as a frontier of exploration, a stepping stone toward interplanetary expansion. That this swarm should draw near to Mars as it passes is almost poetic, as if the interstellar realm itself were paying a visit to the very planet that humans hope to reach next. The proximity adds a layer of immediacy, suggesting that our first human expeditions to Mars might one day encounter similar travelers. It emphasizes the continuity between local exploration and cosmic discovery, tying our next steps outward to the vast journeys already unfolding before us. From an observational standpoint, the multiplication of objects provides redundancy and resilience. With a single body, the chance of close study is fleeting, dependent on perfect alignment and fortunate timing. With many, astronomers gain multiple chances to capture detailed data. If one object proves too faint or too unstable, another may serve as a better candidate. This swarm therefore acts as a living laboratory, a cascade of opportunities spread across weeks and months instead of a singular transient moment. The possibility that some of these bodies carry unusual properties cannot be dismissed. Interstellar material does not always conform to the familiar. Already, prior objects like Oumuamua challenged assumptions with its peculiar acceleration and shape. With multiple objects now available, patterns might emerge, showing whether such anomalies are rare quirks or common features. If several of these companions display non-gravitational accelerations, astronomers would need to rethink the physics of interstellar comets and asteroids, perhaps pointing to structural fragility or exotic compositions. For planetary defense specialists, the multiplication raises both concern and opportunity. Though none of the objects pose an immediate threat, the swarm demonstrates that interstellar bodies may not always arrive in isolation. Planning for potential future encounters must now consider the possibility of clusters or fragmented trains of material. Understanding how these groups move, spread, and evolve is essential for refining long-term monitoring systems. Yet the data gathered here also enriches strategies for deflection or mitigation, teaching how fragmented bodies might respond to gravitational nudges or energy inputs. On a more philosophical level, the event deepens humanity's awareness of belonging to a larger cosmic narrative. These objects have traveled for uncounted eons across interstellar distances, carrying within them the dust and ice of regions no telescope can yet image. Their arrival here is not simply a scientific gift, but a reminder of connection. As they pass Mars, as our instruments follow their fading arcs, we glimpse not only their material makeup, but also the threads that tie our solar system to a wider galactic tapestry. The multiplication of objects becomes a metaphor for abundance, for the richness of encounters waiting beyond the familiar boundary of the sun's domain. The anticipation surrounding 3I Atlas and its companions grows with each passing day. Observatories across the world are coordinating, their schedules adjusted to follow the swarm. Data flows between agencies and universities, uniting scientists in a shared effort to decode what these bodies reveal. The story is not static, it is unfolding moment by moment, with each new detection reshaping models and expectations. The sense of being on the edge of discovery, of watching something unprecedented take shape, infuses the scientific community with excitement rarely matched since the detection of the very first interstellar visitors. As Mars draws closer to this caravan, the potential for serendipitous interactions increases. A faint meteor shower in the thin Martian atmosphere, sparked by particles shed from the swarm, could mark the first interstellar meteors to be recorded on another planet. Instruments tuned to atmospheric flashes may catch glimmers of light, silent evidence of cosmic travelers dissolving into Martian skies. Even if such displays are faint, their symbolism would be profound. The meeting of interstellar matter with the world that humanity seeks to call its second home. In the broader sweep of astronomy, the multiplication of these objects signals a turning point. For centuries, humanity's catalog of celestial visitors was confined to comets and asteroids of solar system origin. The arrival of Oumuamua cracked that boundary, Borisov widened it, and now 3I Atlas and its companions transform it entirely. No longer can interstellar objects be considered singular oddities. They are part of the dynamic flux of the galaxy, and their presence near Mars serves as both proof and promise that more will follow. Each new arrival will not be a stranger, but a continuation of a pattern, a steady reminder that the solar system is not isolated but open to the currents of interstellar exchange. With so many questions unfolding, speculation naturally races ahead. Could any of these bodies harbor complex organics, frozen relics from other planetary systems? If so, their passage near Mars, studied with the instruments humanity has stationed there, could bring the closest examination yet of prebiotic chemistry beyond our system. Such a finding would not only reshape theories of cosmic chemistry, but also deepen the discussion of panspermia, the idea that life's building blocks wander between stars. The very act of multiplying, of bringing several samples instead of one, magnifies the chances of such revelations. The approach of 3I Atlas and its companions is not simply a spectacle, but a convergence of opportunity, curiosity, and possibility. Each fragment, each faint point of light carries the weight of mystery. Together, they compose a narrative of cosmic wandering, of ancient journeys culminating in a fleeting rendezvous near the Red Planet. To witness them is to stand at the threshold of interstellar awareness, to recognize that the galaxy itself occasionally draws close, offering glimpses of its hidden abundance. The swarm will not remain forever. Their paths will carry them past Mars, through the solar system, and back into the darkness beyond. But in this moment, as they multiply and as Mars becomes their stage, they remind us of the vitality of discovery. They invite us to look outward, to measure, to question, to imagine. They reaffirm that the universe is not a static backdrop, but a living expanse, full of arrivals and departures, where even the most distant journeys can, for a brief time, intersect with our own. The deepening spectacle of 3I Atlas and its multiplying companions continues to unfold as Mars's orbit becomes the looming stage for this celestial procession. Each day that passes brings fresh data, sharper images, and new mysteries that reshape our understanding of what it means for interstellar visitors to enter the domain of the Sun. The sheer multiplication of objects demands careful attention, not only because of their scientific significance, but also because of the cultural, technological, and exploratory resonance their arrival creates for humanity. What had once seemed like a solitary interstellar cometary body has transformed into a grand procession, and with each revelation, the event takes on layers of meaning far beyond the raw measurements of orbital mechanics. The unusual aspect of this multiplication is the sheer persistence of the swarm's cohesion. Objects traveling through space at such velocity would ordinarily drift apart, scattering along diverging courses as gravitational perturbations pulled at them. Instead, 3I Atlas's companions maintain a strange kinship, their positions suggesting an underlying mechanism that preserves their collective shape. Astronomers have theorized about weak gravitational binding, but the speeds involved make long-term cohesion improbable. Others speculate about electrostatic interactions or hidden volatile processes producing sublimation jets that subtly adjust their alignments. Whatever the mechanism, the phenomenon offers a new category of astrophysical puzzle: the interstellar convoy. Telescopes tuned to different wavelengths capture diverse profiles of the swarm. Infrared observations reveal warmth radiating from some fragments, hinting at icy surfaces awakening under solar exposure. Ultraviolet studies show outgassing that leaves faint trails, ephemeral signs of volatile material escaping into the void. Radio instruments detect scatter patterns that imply dusty halos around several bodies, possibly indicating layers of fine particles sloughing away. By themselves, these phenomena are not extraordinary. Comets within our solar system behave similarly, but their presence in a group of interstellar objects suggests a shared evolutionary process that began far outside the protective bubble of our heliosphere. The implications for planetary science are profound. Our models of planet formation often rely on examining the remnants left behind in our own system: Kuiper belt objects, Oort cloud comets, and asteroid fragments. Yet those are bound by a common ancestry under the influence of the Sun's gravity and radiation. Interstellar caravans like 3I Atlas and its companions represent snapshots of entirely different systems, preserved by cosmic cold until chance trajectories send them into our observational reach. Studying these visitors is like comparing notes across star systems, broadening the sample size of planetary formation environments. Each composition analysis, each mass estimate, becomes part of a comparative database that stretches beyond the Sun's nursery. The nearness of Mars as a stage in this unfolding drama cannot be overstated. Earth-based astronomers observe through the veil of atmosphere, contending with weather, turbulence, and the limits of even the largest telescopes. Mars, on the other hand, is ringed with orbiters and graced with rovers on its surface, all carrying instruments meant to probe dust storms, mineral compositions, and subtle atmospheric changes. Redirected toward the sky, these same instruments become tools for interstellar study. High-resolution cameras designed to map Martian terrain can capture the faint arcs of passing fragments. Spectrometers built to study Martian rock can analyze the reflected light of cosmic wanderers. Mars, in this context, becomes not only a planet of exploration, but also a platform for astronomical outreach, its robotic emissaries serving as our cosmic observatories. The multiplying bodies also stir debate about the long-term dynamics of such swarms. Do they typically survive intact for millions of years, or do they usually disperse into isolated fragments after only a short cosmic time? If swarms like these are common, then the galaxy may be filled with drifting families of objects, each carrying the chemical fingerprints of their birthplaces. This would suggest that material exchange between stars is not a rare event, but a widespread mechanism, enriching the interstellar medium with diversity and complexity. Such a perspective shifts how we view galactic ecology, placing small wandering bodies as the carriers of memory, the seeds of interstellar interchange. For mission planners and engineers, the passage of a swarm near Mars generates tantalizing dreams. Though it is far too late to launch a probe to intercept 3I Atlas or its companions during this passage, the event highlights the importance of readiness. If future interstellar objects multiply in this way, robotic flybys or sample return missions could be designed not for single targets but for small fleets. The logistical advantage of encountering multiple objects in a single mission cannot be overstated. Each pass offers comparative data, sharpening understanding of interstellar diversity. 3I Atlas may therefore catalyze a shift in mission architecture, inspiring proposals that anticipate swarms rather than lone travelers. The cultural imagination, too, is ignited by the spectacle. Humanity has always woven meaning into the appearance of celestial phenomena, from comets as omens to eclipses as divine alignments. In the modern age, the multiplication of interstellar visitors becomes a narrative of abundance, of cosmic generosity. Artists, writers, and visionaries draw on the imagery of a caravan of stars, a procession of celestial nomads crossing the threshold of Mars. The metaphor of migration resonates deeply, connecting human histories of wandering and exploration with the cosmic journey of these bodies. The event, in this sense, becomes not only an astronomical fact but a myth in the making, embedding itself into the shared cultural imagination. Beyond symbolism, the swarm poses intriguing scientific opportunities concerning organic chemistry. Interstellar objects, forged in environments different from our sun's, may carry complex molecules frozen within their icy mantles. The sublimation now occurring as they near the sun releases not only gases, but potentially organics preserved for billions of years. If Mars-based instruments or Earth-based observatories capture spectra revealing amino acids or precursor molecules, the discovery would ripple across disciplines. The question of how life begins, whether seeds of organic chemistry travel between stars, would gain fresh momentum. The multiplication of objects amplifies this chance. Instead of a single frozen archive, humanity now has access to a library of samples carried by multiple carriers. Another intriguing dimension lies in the dynamics of observation. Tracking a single interstellar object is already a challenge, requiring precise coordination and rapid data collection before it vanishes into the darkness. Tracking a swarm, however, transforms the task into a symphony of coordination. Different observatories must specialize in different fragments, ensuring no piece of the puzzle is missed. Data must be stitched together across networks and time zones, creating a living map of motion and composition. This collaborative effort itself becomes a rehearsal for the future, training the scientific community in the skills required to study transient, complex phenomena that do not conform to expectations. Speculation inevitably reaches toward the exotic. While mainstream science proceeds with caution, some wonder whether the unusual cohesion of the swarm hints at processes not yet fully understood. Could gravitational influences from an unseen, larger mass have shaped their trajectories before they entered the solar system? Might they be remnants of a disrupted exoplanetary system, carrying fragments of moons or asteroids once bound to a distant star? Each hypothesis opens new avenues for research, grounded not in fanciful imagination but in the recognition that the galaxy is richer and stranger than our models often allow. The multiplying swarm forces humility, reminding scientists that discovery often begins where assumptions fail. The timing of this event is particularly significant because of the technological readiness of the human species. Unlike past centuries, when celestial wonders could only be recorded by eye, today's world brims with sensors, satellites, and computing power capable of analyzing terabytes of data. Artificial intelligence aids in identifying faint signals among noise, reconstructing trajectories with precision impossible a generation ago. As a result, the multiplication of objects becomes not just an astronomical curiosity, but a showcase of technological synergy where human curiosity meets machine capacity to extend perception. The swarm demonstrates not only what the cosmos offers, but also what humanity can now grasp. Mars itself, standing as the near-term horizon of human expansion, adds resonance to the event. The idea that interstellar visitors should pass so near to the planet that humanity is preparing to set foot upon creates a narrative symmetry. As humanity prepares to move outward, the cosmos delivers a reminder that visitors from beyond also come inward. This dialogue between human exploration and interstellar migration underscores the continuity of movement in the universe. It suggests that the boundary between local exploration and cosmic encounter is thinner than often imagined, a threshold that can be crossed both by spacecraft and by wandering bodies from afar. The swarm also reshapes how scientists consider the preservation of information in space. Each fragment of 3I Atlas is not merely rock and ice, but a time capsule, preserving conditions of an alien system. By multiplying, the swarm provides redundancy, ensuring that even if some fragments are lost, others remain to carry the record. This redundancy mirrors biological systems where information is preserved not in a single strand, but in multiplicity, allowing survival through change. The event, in this sense, hints at an almost biological metaphor. The galaxy spreads its information in clusters, ensuring that memory survives the harshness of interstellar drift. In classrooms around the world, the multiplying interstellar swarm sparks new lessons. Teachers explain orbital mechanics, chemical spectra, and planetary science through the lens of the unfolding event. Students imagine caravans of icy bodies wandering across the galaxy, carrying the fingerprints of alien stars. The event becomes a teaching tool, a living example of science in progress, where discovery is not finished but ongoing. Young minds, inspired by the story of 3I Atlas, may choose paths of study that lead them toward astrophysics, planetary science, or exploration, continuing the cycle of curiosity that propels humanity forward. As the fragments stream past Mars, the possibility of unexpected interactions remains. Dust grains released from sublimating bodies may intersect with Mars's thin atmosphere, producing interstellar meteor trails faintly visible to orbiters. Instruments could record the composition of these grains as they burn, offering data without the need for direct sampling. The very atmosphere of Mars becomes a detector, a canvas on which interstellar material writes brief signatures of its passing. Such interactions add depth to the study, revealing not only the objects themselves but also their influence on planetary environments. In considering the long arc of history, the passage of 3I Atlas and its multiplying companions may be remembered as a threshold moment. It redefines expectations about interstellar visitors, transforming them from solitary anomalies into potential collectives. It broadens scientific horizons, showing that encounters can be richer and more complex than anticipated. It strengthens cultural imagination, offering metaphors of migration, abundance, and cosmic kinship. Above all, it reminds humanity that the universe is not distant and unchanging, but dynamic and interactive, filled with moments of encounter that carry both knowledge and wonder. The multiplication of interstellar objects near Mars is a gift of both science and symbolism. It challenges astrophysicists, inspires visionaries, and stirs the curiosity of countless observers who look to the night sky and feel the thrill of connection. These fragments, drifting together across the solar system, carry with them stories from beyond the sun, stories now unfolding within the reach of human perception. Their passage invites us not only to measure and analyze, but also to marvel, to recognize that in the vast silence of space, surprises still multiply, and encounters still come unbidden. full of meaning and mystery. The precession of 3I Atlas and its companions has become one of those rare astronomical events that stretches the imagination beyond what even specialists dared to expect. With each passing day, as instruments refine their measurements and observational campaigns expand, the phenomenon refuses to settle into predictability. Instead, it grows richer, stranger, and more layered in significance. The fact that this unfolding takes place in proximity to Mars deepens its symbolic and practical weight, turning the red planet into a witness and participant in a drama that transcends planetary boundaries. What began as a single discovery now evolves into a multidimensional event with consequences for astrophysics, planetary science, philosophy, exploration, and even the arts. One of the most striking aspects of the multiplying objects is how they challenge the linear expectations of cosmic encounters. Traditional cometary visits within the solar system have a rhythm: detection, observation, perihelion passage, and departure. But the 3I Atlas swarm behaves more like a narrative unfolding in chapters. New companions are identified at intervals, their properties emerging in a staggered fashion. This drip of discovery forces a sustained engagement rather than a single burst of attention. It becomes a prolonged story, demanding continuous adaptation from the global scientific community. The event is dynamic in a way few astronomical phenomena have ever been, each update rewriting the script rather than simply adding footnotes. At the core of scientific fascination is the potential for these objects to illuminate the diversity of planetary system chemistry. Already, preliminary spectra suggest subtle variations in composition among the companions, with some dominated by carbon-rich compounds while others display stronger water-ice signatures. Such heterogeneity implies a complicated history, perhaps even a collective born not of one parent body, but of several objects bound together by chance or mutual gravitational capture. This possibility expands our understanding of how interstellar debris might travel, not as monolithic fragments, but as communities shaped by earlier interactions. If true, it would suggest that interstellar space is more socially dynamic than previously imagined, a place where wandering bodies can form temporary alliances before encountering new stars. Mars's orbit, standing as the immediate stage, brings another layer of opportunity. Its gravitational field, though weaker than Earth's, will still influence the swarm in subtle ways. These gravitational nudges may alter the paths of individual fragments, providing natural experiments in celestial mechanics. The swarm's passage near Mars allows for real-time study of how interstellar bodies respond to planetary encounters, offering analogs to what might occur if such objects were to approach Earth. Astronomers and dynamicists can use this event to refine models of planetary scattering, adding a new dimension to the already complex equations that govern cosmic motion. The Martian atmosphere itself could serve as a participant in the event. Even though Mars's air is thin, it is not negligible. Should particles from the swarm interact with it, their disintegration could produce luminous streaks, faint meteor showers invisible to human eyes on the surface but detectable by orbiters and landers. Such interstellar meteors would be the first recorded on another planet, a milestone in planetary observation that connects the Martian environment to the broader galactic story. For planetary scientists, this represents an unprecedented opportunity to witness how alien material interacts not just with our instruments, but with the natural systems of another world. Equally compelling is the way this event reframes the concept of planetary defense. For decades, the field has been oriented around the threat of Earth-crossing asteroids and comets. Interstellar bodies, though exotic, were considered too rare to warrant major defensive planning. The emergence of 3I Atlas as a multiplying swarm forces a reconsideration. If interstellar objects can arrive not as individuals but in groups, the statistical landscape of potential encounters changes. Even if none of the current swarm poses a hazard, the principle is clear. One day a convoy of fragments might cross Earth's orbit. Preparing for such scenarios requires expanding defensive models beyond isolated threats toward collective ones. This broadening of perspective is one of the quieter but most consequential legacies of the current event. Meanwhile, the multiplying objects also influence discussions about interstellar exploration. For decades, the dream of sending probes to nearby stars has seemed daunting, requiring propulsion systems far beyond current capabilities. But events like 3I Atlas remind us that interstellar material also comes to us, crossing our doorstep without invitation. By developing the ability to study these bodies closely through rapid response missions, improved detection networks, and perhaps even Mars-based observatories, humanity could begin sampling interstellar material long before it can send spacecraft to Alpha Centauri. The swarm near Mars highlights a shortcut to interstellar science. Instead of always going outward, sometimes we can simply be ready when the galaxy delivers material inward. The human imagination thrives on patterns, and the Caravan of 3I Atlas invites metaphor. Poets and artists describe it as a cosmic migration, a caravan of icy nomads carrying messages from afar. Philosophers interpret it as a reminder of impermanence, of how all things, even celestial bodies, travel, fragment, and disperse. Religious voices may see in the multiplication a symbol of abundance, a sign that the cosmos is generous rather than barren. Each perspective reflects the way astronomical events ripple beyond the scientific domain, entering the shared well of human meaning. The event becomes a cultural anchor, remembered not just in equations and charts, but in stories and symbols. On the technological front, the event accelerates innovation in observational coordination. Because the swarm requires distributed observation across multiple bodies, institutions worldwide have had to collaborate at an intensity rarely seen. Space agencies, universities, and independent observatories synchronize their efforts, sharing data in near real time to construct a holistic picture of the swarm. This level of coordination foreshadows the future of astronomy, where complex transient phenomena demand networks rather than isolated efforts. The multiplying swarm acts as a rehearsal for this future, teaching the scientific community how to act as a single distributed organism of perception. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas multiplying objects near Mars? We want to hear from you. Thank you for watching, and see you next time.